Section 4.5 is getting a little deeper into integration and a little more suggestions on how to integrate stuff. So what we're going to first look at is a pattern recognition. And I'm basically, we're going to talk about it, but I'm going to show you the U substitution way because I think it's a lot easier, and I think you're going to use it a lot more. But anyway, what this pattern recognition is saying if we're doing basically the opposite of the chain rule is what's going on. All right, so what it's saying is if we're taking the integral of a function, all right, and so we have a function inside of a function is what we have. So it'd be like x plus 2 squared. If we have something like that, if we have a function inside of a function, and then it's times, if it's multiplied by its derivative of the inside, so the derivative inside, which would be, in this case, would be 1. Kind of a bad example. Maybe I make this x squared. So maybe it's times 2x, like this out here, all right? If we recognize that pattern, it's just the integral, all right, of this outside function right here. Okay, so in this case, it'd just be the integral. We just take the integral of this outside. So, and this drops off. All right, and it's still going to be, this is going to be left over inside. We're going to increase our power by 1, and we're going to bring down and divide by the new power. All right, so if we recognize that pattern, we can just take the integral of the outside of that little function in there, okay, and leave the inside alone. That's why it's the opposite of the chain rule. And I'll show you the U substitution here when we get to example. All right, so I was talking about the outside function, inside function. This is just showing you a diagram of the outside function would be the f. All right, so here's the outside function in green. All right, the inside function is here. All right, and if we notice that we have the derivative of the inside function is being multiplied by the outside function, this guy just cancels out. We leave the inside the same, and we take the derivative of the outside. All right, I'm going to show you though. All right, a U substitution, and I put it down here, and if I let g of x equal u, all right, then we can take the integral with respect to u. All right, and this is going to make more sense when I do this derivative over here. And we can do it both ways. We can recognize a pattern. If you look inside here, we have a function inside of a function, x squared plus 1 squared. So this would be like your inside function. This x squared part is your outside function. And here, if you notice, is the derivative of the inside function. It's the derivative of x squared plus 1. All right, so what we just found out is this actually cancels out, and then we just take the integral of our outside function. So we'd increase the power by 1, divide by the new power. All right, what I'm going to show you, that last thing, that U substitution, is what we do is we make this inside equal U. All right, so we're going to substitute. So what we have over here is we have U squared. So we have U equals x squared plus 1. If I take the derivative of U, I'll get du equals 2x dx, because I took the derivative with respect to x. Right, and then I want to solve for dx, because what I'm going to end up doing is I'm going to substitute in for here. Because I changed this to a u, it's now u squared du times 2x, and we're still taking the integral. All right, so what I want to do is I want to substitute this dx and make it a du, because we want to take the integral with respect to u. All right, so let's solve for dx. So I get du over 2x equals dx. So I'm going to substitute this in for my dx, because that's what dx equals. So now I'm left over with the integral of u squared and times 2x times what dx is du over 2x. Notice these cancel out. That's why that pattern works. Those two cancel out, and I'm just left over with the integral of u squared du. So we're taking the integral with respect to u. All right, so when we take the integral of that, we add 1 to the power, divide by the new power. So we get u cubed over 3 plus c. All right, and then when the last thing to do is just left over is just to go back and plug our u in. So x squared plus 1 cubed all over 3 plus c. All right, and that's what we would have got earlier if we would have just recognized the pattern like we talked about here. We just would have taken the integral of the outside, all right, and left the inside alone, and then the derivative of the inside canceled out. All right, but anyway, I like the U substitution because I think we're going to use it a lot more. So for number 2 here, I'm going to use the U substitution. Remember when we had a cosine, we always said if you type cosine in your calculator, you're going to get cosine parentheses 5x parentheses. So what we're talking about is this inside function is the 5x is your inside function. All right, so let's make our inside function u. So cosine, so 5 cosine of u. Make u equal 5x. Well, okay, so let's take the derivative. Du equals 5 dx. And let's solve for dx because we need to plug in for dx here. All right, so let's solve for dx. So I have du all over 5 equals dx. And now let's substitute in for dx. So now I have du all over 5. All right, if you notice, it's saying 5 times cosine. All right, so this 5, we can cancel those out. All right, and we're just left over then with the integral of cosine of u du. The integral of cosine is sine, so it's going to equal then the sine of u, and we go ahead and we plug our u back in, so the sine of 5x, then plus c. All right. So the next one. Let's check the next one out. We have a function inside of a function, all right, multiplied by another function. If you recognize a pattern, all right, it's not quite the derivative. This outside here, this x right here, isn't quite the derivative. But because I've shown you this u substitution, I think it's going to make sense. All right. So we're going to take the inside function. All right? This guy is being squared, so it's going to be our inside. It's going to be our u. So I have the integral of x times u squared dx. Well, we want to get rid of this x and this dx. We want to get them to cancel out. So let's go u equals x squared plus 1, because that's what we let u equal. All right, let's take the derivative and solve for dx. So du equals 2x dx. Solve for dx, I get du all over 2x equals dx. And let's plug that in then into here. All right, let's plug that into here. So I have the integral of x u squared, all right, du over 2x. All right, if you notice, I'm multiplying here, so I can cancel. This x cancels out here. All right, so what I'm left over is the integral of u squared all over 2 du. Or what you guys know from integrals is we can pull that 1/2 out. All right, so it's the same thing as 1/2 times the integral u squared du. And then we add 1 to the power. All right, divided by the new power. So I have 1/2 times u cubed all over 3 plus c. And then the only thing left to do is plug u back in there. So we're going to have, let's see, 1/6. Sorry, that got a little messy. 1/6 times what's u is x squared plus 1 cubed plus c. And that's your final answer. So the only difference that happened is we ended up having to pull a 1/2 out is what we ended up having to pull out. Okay? Oh, let's keep going. Change of variables. This change of variables is just talking about the u substitution that I've already shown you. All right? So I've showed it to you already. So let's go ahead and let's evaluate this integral already. Okay? So evaluate the square root of 2x minus 1. Well, here we have an inside function. All right? So we have an inside function, so we're going to say the integral of u to the 1/2 power. Let's make 2x minus 1 equal u. So let's figure out what dx is so we can substitute in for it. So du equals 2 dx, because we took the derivative with respect to x. Divide by 2, so du all over 2 equals dx, right? Okay, so instead of having dx in there, all right, I'm going to substitute du over 2. All right, well, this is easy enough. We just pull this 1/2 out to the outside and take the integral of u to the 1/2 du. And how we do that is the same way we've been taking integrals all year. All right, so we add 1 to the power, so add 2 over 2, and divide by the new power. So we're going to have 1/2 times u to the 3/2 power. We're going to divide by 3/2, which is really multiplying by the reciprocal 2/3 plus c. And then we can cancel out. So we're just left over with, 1/3 u to the 3/2. Let's go ahead and plug our u back in there. All right, so we're going to have 2x minus 1 to the 3/2 power divided by 3 plus c. All right, and that's how you take the integral of that function right there. Just some more examples of u substitution. skipped a few there. All right. The next one here. Well, we have something inside. We have a function inside of a function. All right. So we can make the inside equal to 1/2. All right, equal to u. So let's let u equal 2x minus 1. All right. So we have the integral of x times u to the 1/2 power dx. All right. So then let's take the derivative. So du equals 2 dx. All right. So then we'll go ahead and we'll solve for dx. So du all over 2 equals dx. Now I'm missing something here. Okay, here. All right. What we need to do, all right, we solve for dx. So we're gonna plug du over 2 in for dx. So we're left over with x u to the 1/2 power du all over 2. Now you'll notice something different about this problem. We don't have anything that's going to cancel out with this x. All right, we don't want to deal with x because so far now we made a substitution. We want to take the integral with respect to u. But what we can do is we can solve for x up in this problem right here and then substitute what x equals in terms of u. All right, so we can solve for x. So let's go ahead and subtract or add 1. So we'll have u plus 1 equals 2x. All right, and then divide. So x equals u plus 1 divided by 2. We can go ahead and substitute then what x equals. So we'll have the integral, all right, of this, u plus 1 divided by 2 times u to the 1/2 power du over 2. All right, so this is all multiplication, okay? All multiplication, so we can go ahead and pull out anything in the denominator. It looks like we have a 2, we have 1/4 in the denominator. We can pull a 1/4 out. All right, so we have a 1/4. We have a 1/4 integral then. So we pulled this 1/4 out, then we just need to distribute our u to the 1/2 in there. All right, so power to power, or when you multiply the same base with powers, you add, right? So we have u to the 3/2 plus u to the 1/2. All right, then everything's the same. We just take the integral, we add 1 to the power, divide by the new power for both of these. All right, and it's all times 1/4. Because of time constraints, I'll just assume that you can finish the rest of this. When you get done, you'll plug u in. All right, you'll plug this in for u when you get done taking the integral of that, and you guys can do that. All right, you can add 1 to the power, divide by the new power, and you'll be able to do that, and add c at the end. All right, why? Because I need to get this done here in a couple minutes, and this problem right here is one of them that I wanted to talk about. All right, so we want to evaluate this integral, sine squared 3x cosine of 3x. So we can rewrite this as sine of 3x squared times cosine 3x dx. If you notice, we have our function that's inside. All right, I have another function. All right, we have our inner function, which is going to be u. So let's make u equal sine of 3x. So then du, we need to take the derivative, which actually we need to do the chain rule. All right, so here's our inside, and the sine is our outside. So we take the derivative of our outside, leave the inside the same. So derivative of sine is cosine, leave the inside the same, and then we need to multiply that then by, all right, the derivative of the inside, which is 3 dx. All right, and again, we'll solve for dx. So we'll have du all over 3 times cosine 3x equals dx, and we're going to plug that in here for dx. All right, if you notice, when we plug that in here, our cosine 3x are going to drop out. All right, and I can pull a 1/3 out in my integral. So I'll have my 1/3, that comes from right here, okay? And then we'll have u squared du. And that's it. And then we'll take the integral with respect to u. All right, so we'll add 1 to the power, divide by the new power, and then we'll plug u back in, and I'll let you figure out the rest of that integral. I just wanted to show you what we did for a substitution and remind you of the chain rule here that we need to do to complete this derivative from here to here. All right, I hope this helps. We'll see you in class tomorrow.